Hello everybody, today I will do complete test review of UT 513A, which I just took from the warehouse. We will do unboxing, I will show you all the functions, even the measuring in permanent short, how it works, how it looks. And then we will tear down this meter, take a look inside, what's the construction, how it looks, how it feels. I have also a simple diagram here for you to explain more. And in the very end, I will invite you to my home, where I have some new electrical wire installation. So I will show you the actual practical measurement. This will be one great review today. So start with the unboxing. We have UT513A here, which is improved old 513. And the main improvements are that the new meter 513A is not freezing during the permanent short. It continues the measurement, and it also measures the actual value on the display, so you know precisely what is the testing voltage. As you can see, the meter is in a plastic box, which is kind of tough, very easy to wash. You can put it into the trunk with other tools. It will be enough protection for your meter. Now what we have, the manuals, English, Czech, the 3 testing leads, the green, black and the red. I will talk about them a little bit later. The meter itself, USB connector for connection to PC, 8 1.5 volts batteries, C-type, and power adapter. So let's load the batteries inside and take a look what it does, what it can do, what are the functions. Okay, so let's load the batteries inside. The back cover is fixed with one screw. There is nothing special to see here. A serial number, some warning, remove test leads before opening, read manual, cut 3 600 volts. And underneath we have space for 8 batteries. Not the small one, but the bigger one, the C-type. Let's load the batteries inside. Screw the cover back. And we are ready to go. So, the meter itself, it is quite large. It weighs about 2 kilos. The test lead terminals are very deep, so there is no way you can put your finger inside. Just take a look at this. Take a look at this, how deep this goes. You can see it's pretty safe. But yes, we are generating 5000 volts, 5 kilovolts, so it should be this way. So let's talk a little bit about the functions. So let me turn the light on so you can see better the backlight. And maybe we start with the construction from the outside a little bit more. As you can notice, the display is pretty huge, with a blue backlight and a bar graph. What is very nice, this meter can connect to PC via the USB port, which is completely safe, completely isolated, as I will show you later. And we also have input for power adapter, which can supply 15 volts DC up to 1 amp. Nothing special about the power supply. Just this connector is also quite deep, so you have to put the connector very deep. So again, you are not touching anything potentially dangerous. We have 3 probes with a large alligator clip on the end, which is not removable. It's not possible to remove this part. And we have line, earth and what I think green and black probes, which goes to these terminals. So you can see it switched off because this meter has automatic power off feature when it's not measuring. Let's turn it on again. So we can choose between testing voltage of 500 volts, 1000, 2500 volts and 5000 volts, 5 kilovolts. Besides the insulation resistance, the meter can also measure DC voltage and AC voltage, but only up to 600 volts. And regarding this insulation resistance, the accuracy is kind of normal for these devices. It's within 3% plus 5 digits. All this is auto range. The resistance value is showing automatically, you don't need to switch anything. Also, there is memory inside for 18 values, which you can load, save, then read through PC. And very interesting is that this device also have timers. Because if you set timers, you can do another types of measurement. You can measure comparison measurements when you have preset values, 10 mega ohms for 5 seconds. You can choose the time. You can also change the value 20 mega ohms, 30. And it will measure for the period of time you put inside and compare if your value is higher or lower than this. Besides that, it can measure polarization index, PI, and dielectric absorption, DAR. So it's a pretty handy device. And what I really like is when, let's say, we can generate 5 kilovolts. Let's turn the test on. You can notice this button is becoming red when the device is generating the voltage. Oh, we have nothing attached, so this is overload now. This is infinite resistance between the terminals, and we can see we have 5K and 230 volts on the output. Yeah, so perhaps now is the time to demonstrate how it looks when we go into short and how it performs during a permanent short. Alright, so let me turn off the light and we are ready to go. 5 kilovolts and a permanent short. We also switch the light on, and I have a screwdriver attached here. It's not very safe, but I take the risk. You don't measure like this. And I attach the ground to one of the terminals, and let's look at what happens. You see the sparks? Wow! A lot of sparks. I am sure you want to take a closer look. So let's observe this a little bit more. I was always fascinated with electricity, so this is interesting test. Yeah, it's really kind of funny to play with this. Let's do it again. Wow! So many sparks. Also, let's look what the display is measuring. We have 5 kilovolts, but as we go to the short, the voltage of course drops. The reason is that the DC multiplier cannot provide such high voltage for a very long period of time. But you actually know what is going on. You see the values, multimeter is not freezing. Oh, let's do a close look on this. So this is the fun part, and now we go to another very interesting part. We will look what is inside this machine. I will disassemble it for you, and we will take a very close look at all the components inside. I hope you like it so far. Okay, so I opened UT513A. Nothing special on the back side, just battery positions for screws. And we have a USB here with a power supply connector. This is connected to the second board where we have some logic circuits. Display is actually on the other side of this high voltage part, and I will show you very briefly what's the principle of function. Alright, so we have a very small DC voltage, so 15 volts from an adapter, or 8 times 1.5 volts from C batteries. We have this power through wires here, and now we need to generate much higher DC voltage. So what we do? First we transform this small DC voltage into high frequency small AC voltage. We use a switching power supply or switching transformer with MOSFET switching transistor and high frequency transformer with ferrite core. That way we transform this high frequency AC up, so we have higher levels AC, very fast AC. We again make this DC, we rectify this and smooth this, so now we have a higher DC. But to reach 5K we need to use a DC voltage multiplier here, which basically consists of a set of capacitors and diodes in a special circuit. I will show you how it looks. Yeah, so this is, I already removed this cover because all this high voltage part is in a small, I call this fish tank. And you can see all the components are under very thick layer of insulation gel, which is all around. And this is what I was talking about. We have capacitors, diodes, so that way we multiply the DC voltage up to 5K. Here is the high voltage relay, which is designed up to 10K, 10,000 volts. If we take a look at the rest of the board, here we have some logic circuits. Here is the wires which bring the power from the batteries or from DC adapter. And to also take a look how this USB port is solved, because it might be you know, we have 5,000 volts, we have our computer, and now we connect these two together. So I will assure you this is completely safe. Take a look at those cutouts. This prevents any high voltage to get from this part up to here. And all the data transmission, all the connection is done through light via LED diodes. I think those are infrared light, so this is pretty safe. All these circuits are powered from USB and just the communication is through light. You may also notice we have some other high voltage isolation cutouts on the board. Here under the Omron relay, and of course in this fish tank we have isolation slots here, isolation cutoffs. Here is another one, and here. So the construction itself is pretty clever, and it was reviewed, no, not this model but the previous one, UT513 by Dave from EVV blog, and he also considered the construction pretty okay. If you watch his video, you may notice this part is a little bit changed. I think he had two small transistors. Here we have now one big high power switching MOSFET transistor. But yeah, this is a really upgraded version, a better one. I was talking what are the enhancements. It's not freezing anymore, and it measured the voltage, so it's much better. So this is the construction. I hope you like how it looks. Yes, also here you can see the input terminals. And the last part of the video I will show you practical demonstration how to measure some new wires installed in the wall, and also will mention why it's important to measure insulation resistance, what could happen. So this will be in the last part of the video. Okay, so today we are at the construction where I have some new electric cables in an old wall. This will be power socket soon, and I want to make sure that this cable is okay. So I will measure the insulation resistance in between the conductors. So let's try the test. We are testing with 500 watts here, and it's overloaded, so those two conductors are okay, safely isolated. And there is plenty of a way what could be wrong. You may use some older cable which might be pinched, or somebody driving over it, or anything else, and you can always test them before you use them, or even if you already have them in the wall, you can test it. All electricians must test the new installations anyway, but you can also double check if you have insulation resistance testers. And a special case is heating cables. If you have heating cables in the floor, there is nothing worse than not checking the insulation resistance, put the concrete over the tiles, and then realize that the cable is wrong. So it's extremely important to test insulation resistance of all electrical installation cables, and also heating cables which are in the floor. So this is a very easy test, but very useful and can save you a lot of time.